This video is about toxicity, specifically the concept of LD50. We're going to start off with a little video by this guy named Paul McNabb. He's a researcher in New Zealand, and he's testing food safety. And he's going to talk about what LD50 is and how they test for it, and then we'll look at a graph of the data and talk about how to create and interpret that. And just a word of warning, he's from New Zealand, so his pronunciation on a couple of things might be a little different. Just pay close attention to what he's saying.
One of the first things we do if we discover a new toxin is do something called an LD50. So it's a lethal dose which kills 50% of the test animals, and that's usually done initially by injection of a toxin into the mouse, and then that would be followed by feeding the toxin to the mouse. It would be most common for toxins to be more potent when injected than when fed, and the difference between those different types of LD50 can tell us about the toxin, how much of a risk it may be. And we've certainly had examples in the past where toxins that are very potent by injection are a lot less potent by feeding. And that means that if we're doing our mouse bioassays to check our food is safe by injection, we're often overestimating the risk, because the risk when the toxin is eaten is a lot less. So we incorporate that information about each toxin into our LCMS test, and then that helps us assess by the LCMS whether the food is safe or unsafe.
Okay, so let's take a look at the graph that he was showing in the background. This is a dose response curve, and it's responsible for showing us as you change the dosage. In this case, we're looking at a logarithmic scale, so we're starting from really small doses and increasing those by an order of magnitude. If you change that, how does that affect the proportion of the population that dies from these different doses? What's missing from this graph is any units for dosage. Common ones include something like milligrams per kilogram, meaning the quantity of the substance per the mass of the test organisms. And then it can also refer to how much is present in the environment, so parts per million. What we're looking at here is data that was collected. So here we have individuals that were given 10 to the -8, let's call it parts per million, of the substance, and 0% of them died. And then by the time we reach 10 to the -5 parts per million, we have 100% dying, which is a little bit extreme. You don't want to have to talk about what dosage kills everybody or what dosage kills nothing. So what we go with is something called LD50, the lethal dose for 50% of the population, meaning 50% of the individuals that receive it are going to die. It doesn't mean the other ones aren't affected, it just means that they don't die. So what we do is we gather our data, give different groups of organisms these different dosages, and see how many die at those different dosages, make a nice smooth curve, and then we go over to this 50% mark and draw a line across, because that tells you at the point where it crosses the line, then you drop that down to the dosage and you find out what the dosage was that kills or could kill 50%, because they might not have actually tested the actual dosage. So for example, in this data set, drug B is killing 50% of the population at 10 to the -6 parts per million. Drug A is more toxic because it takes less of the substance to kill that 50% of the population. So this is potentially more harmful. And then they also show something about how different toxins can interact with each other, and you can have a cumulative effect. Sometimes this is called synergism. They work together because A and B were tested separately, and then both of them were present because, hey, there's a lot of stuff out there and you might be exposed to more than one thing at a time. And that's even more toxic because it kills at a smaller dosage. So again, this is a dose response curve. We are going to collect data by giving different groups of black worms different dosages of alcohol, ethanol, and we'll be collecting data. And then what you're going to do is make your own graphs and determine by the same method what was the 50% death rate, and then dropping down, and this would be your dosage, your LD50, because LD50 is what dose. So what's the quantity of the material that killed 50%? Okay, and that's how you do that.